In section 1.7, we're looking at transformations. So f of x is our original function. That's going to be the parent function. We always want to remember to start there and think about that graph. Now if we have that function f of x and we are going to add or subtract a value to that, again if we add k, then we're moving up k units. If we're subtracting k, then we move down k. Here we're going to take f of x minus h or f of x minus plus h, and remember if we're doing the function before we have plugged values in, if we're going to subtract h from our x values, then that means we're going to move the function right h units. And if we're going to add h to those x values, then we're going to move left h units. If we have a times f of x, this is going to give us a vertical stretch if a is greater than 1. And if it's between 0 and 1 for our a value, then it gives us a vertical compression. Remember, when we're doing this, what we want to do, because we're taking a times f of x, is we're going to multiply all of the y values by a. All right, so that's the big rule here, is to multiply all y values by a. All right, now if that a value is negative, then it's going to flip the graph over the x-axis. Now this time we're going to be multiplying the function, multiplying our x values by a. That's going to result in a horizontal compression if a is greater than 1, or a horizontal stretch if a is between 0 and 1. Now again, our rule here, we're going to multiply all of the, or each of the x values We're going to multiply each of those x values by the reciprocal, or 1 over a, as we're doing this. All right, and we'll show an example to do more of this. It gets a little bit confusing here as we do it, but the way that it reacts to the graph, we're going to multiply each x value by that reciprocal of the a. And if that a value is negative, now it's going to flip that over the y-axis. Let's do a couple of examples. For this example, we have f of x is equal to 2 times the absolute value of x minus 3 plus 5. First thing we want to look at is, let's look at our parent function, which would be the absolute value of x. And if we were to sketch the graph of the absolute value of x, we know we're going from 0, 0, and then as we plug in, we have 1, 1, 2, 2. It's also the same thing over on this side. We have negative 1, 1, negative 2, 2. So that would give us, there's our 5 critical points. That's what we start with, and we can see that this graph is going to look like this, giving us that V shape for the absolute value. All right, next thing we want to look at, second step, is to do the x minus 3. All right, because that's within here, that's the first step we're going to do, and that's going to move this graph to the right 3 units. So now this point here, which was at 0, 0, it's going to go over here 3 units, because if I plug in 3, 3 minus 3 gives us 0, it takes us right back to there. And it's going to do the same thing for every single one of these points. So it's going to move this point over 3 units and moves this point over 3 units. Does the same thing on this side. So now if we look at just the absolute value of x minus 3, that second graph is going to look like this. Now if we want to keep track of some critical points as we're doing this, we could look at our first point here, and at step number 1 for our table with x and y, we have values at negative 1, 0, and 1. Those are these points right here, and we end up with this being positive 0, 0, and 1. So then what happened on our second step, step number 2, when we look at this same table, when we have those x values, now we're going to keep the y values the same. We're adding 3 here, right? That's what we're going to do, is add 3, it's moving it to the right. So we have our values of 2, 3, and 4, still giving us those values of 1, 0, and 1. Now this next part, we're going to take 2 times that value. Now this is going to multiply all the y values by 2. So looking at this step, here's number 3. X's are staying the same. We're still at 2, 3, and 4. Now we're multiplying each of these by 2 for our y values, 2, 0, 2. So when we go over to our graph, if we're looking at those points, we're still here at 0, 0. Now this point multiplied by 2 is going to go up to here, this point to here, and it's going to tighten up this graph this way. Last step now, so we have taken care of 2 times the quantity of the absolute value of x minus 3, and now we have the plus 5, and that's going to move everything up 5 units. And that's going to result in our y values going up 5. So we're adding 5 right here on our y values. X's stay the same, so we're still at 2, 3, and 4. Now we're adding 5 to each of these, so these go to 7, 5, and 7. So if we come over and we look at our graph, we're moving the last one we had there, the blue, we're going up 5 units. So this point's now going to be at 3, 5. Now that point's going to be at 4, 7. And then this one's going to be at 3, 7. And so there's our graph with all of the transformations. Here for another example, we have f of x is equal to negative 4 times the square root of x minus 1. So again, parent function, first thing we want to do is we want to think of just our graph of the square root of x. Alright, so the square root of x, we would have a point here at 0, 0. Plug in 1, it's 1. And if we plug in, let's say we're going to take the square root of 4, that is equal to 2. Square root of 4 is equal to 2. So this gives us our parent graph. That's where we're starting. And if we think of that table for x and y, we just had our points there at 0, 0, and we're at 1, 1, and we're at 4, 2 for that. So then the next thing we're looking at, we have step number 2. I'm going to take the square root of x minus 1. Okay, and what that's going to do now, it's going to move right 1 unit. Alright, so for step number 2, moving each of these points to the right 1 unit. Right there, so our x and our y values, again that's going to move then those x values to 1, 2, and 5. Right, and our y values stay the same on that point, so we're still at 0, 1, and 2, same as we were before. Okay, so the third step then, now we have the negative 4 times what we've already done with our x minus 1. So this negative 4, we're taking times all these values, so that's going to be times the y values, because it's after we've already worked with the parent function here. So we're still going to have these same values of 1, 2, and 5 here. Now what happens when we multiply by a negative? It's going to flip it over the x-axis. And then, because we're multiplying by 4, it's going to give us a vertical stretch by a factor of 4. We're going to multiply each of these y values by 4. So now we're going to have 0, then 1 times negative 4 gives us negative 4, and 2 times negative 4 gives us negative 8. So now when we plot those points, we're going to be at, still at 1, 0. Now the next one's at 2, negative 4, dropping all the way down to here. And then we're at 5, negative 8, falling right off of my graph. It's going to stretch it this way.